All right, let's talk about factories. When you picture one, you're probably thinking of robots on an assembly line, right? Well, we need to update that mental image. Today, we're going to build the factory of the future, literally piece by piece. And this isn't science fiction. This is what's really happening in manufacturing right now.
This quote from Gartner just perfectly sets the stage. I mean, listen to those words, a biological shift. It's not just about making things faster. It's about creating a factory that acts like a living thing, something that can breathe, learn, and evolve. And believe me, that shift is already happening.
So how in the world do you build a factory that can think for itself? Well, we're going to assemble it together, step by step, starting right at the foundation, its DNA. First things first, you need a whole new blueprint, a new genetic code for how things are made. And this isn't about little tweaks here and there. We're talking about a fundamental rewrite of the DNA of production itself. And here is the core concept. It's called the manufacturing double helix. Just like real DNA, you've got two strands twisted together. The first strand is the product itself, but it's defined by its software. The other strand? That's the production process, and it runs autonomously. The real magic is that these two strands are in constant communication, each one changing and influencing the other. And this, right here, this is the paradigm shift. You know, for decades, the name of the game was optimization, just making the same old process a little bit faster, a little bit cheaper. But now, the goal is so much bigger. It's about building a system that can improve itself, one that can adapt and evolve all on its own. Okay, so let's zoom in on that first strand of the helix, the product. Its very essence is changing, moving away from being a static piece of hardware to becoming this dynamic, software-driven thing. Think about it. In the old model, software was just kind of baked into the hardware, like a car from 20 years ago. But now, the code is the updatable DNA of that car. By separating hardware and software development, companies can build both at the same time, which gives them this incredible agility. The car that leaves the factory is no longer the final version. It can get better overnight with a simple update. So what's the real-world payoff for thinking this way? It's this number. 40%. That's not just an improvement, that is a massive competitive advantage. A 40% reduction in time to market for new features. Let's go back to our car example. Instead of having to wait for next year's model to get a better infotainment system, the company can just push out a software update next week. This is what ends the whole era of the static, unchanging product. All right, so we've got a new kind of product that can be updated constantly. Now, who, or maybe what, is going to build and manage all of this? This brings us to the second strand of our DNA helix, a totally new kind of AI that acts less like a tool you use and more like an autonomous teammate. And this is a really, really critical distinction. We're all getting used to generative AI, right? You ask it a question, it gives you an answer. It's a fantastic tool. But agentic AI is a whole different animal. You don't just ask it a question, you give it a goal. It doesn't just respond to a prompt, it actually executes the work to achieve that goal. The key word here is agency. These are systems designed to act on their own. They can take a high-level goal, break it down into smaller steps, figure out what tools they need, like connecting to a database or calling an API, and then just execute that plan from start to finish. Let's make that a little more concrete. Say you need a complicated quarterly report. Instead of assigning it to a team of people, you give the goal to a multi-agent system. You'd have a research agent that goes out and pulls all the data from sales, marketing, and operations. Then an analyst agent sifts through it all, finding trends and flagging risks. And finally, a synthesis agent takes everything and builds a polished, ready-to-go report. Each agent is a specialist, and they all work together. And this isn't just some theory. These are the operating systems for these AI teams that are out there right now. You've got super customizable frameworks like LangChain for heavy-duty engineering. You've got collaborative ones like Microsoft's AutoGen. And you even have no-code platforms like Monday.com AI that let regular business users build their own agents right into their daily workflows. So what does this actually look like on the factory floor? Right now, agentic AI is handling about 2% of key production operations. But by 2030, that's projected to jump all the way to 10%. That's a 5x increase. But what's really important to remember is that humans stay in the loop for the critical decisions. This is all about augmenting human capabilities, not total replacement. And now, we're seeing the physical bodies for this new AI workforce. And these are not just lab prototypes. The Figure 03 robot, it's being deployed in BMW's manufacturing plant. Agility's Digit is already moving boxes around in Amazon warehouses. The AI is literally stepping off the computer screen and onto the factory floor.
So we have our new DNA, and we have the new workforce. Now we need the brain. It's going to coordinate everything. And this is where the whole idea of the digital twin evolves into something way more powerful. For years, a digital twin was basically a passive tool, a cool 3D model that showed you what was going on in your factory. But the closed-loop digital twin, it's active. It doesn't just show you what's happening. It sucks in real-time data, runs optimization models, and then sends commands back to the machines to make adjustments. It actually closes the loop between the digital and physical worlds.
And the impact is huge. By 2030, these active brains are expected to cut both downtime and emissions by 20% in the plants that use them. This is the kind of real-world value that's driving companies to adopt this technology across the board. Okay, so we've built the DNA, we've hired the workforce, and we've installed the brain. Now let's put it all together and see what we've actually created. It's a factory that doesn't just blindly follow instructions, but one that genuinely learns and adapts. So let's just recap the key pillars here. We have that double helix as our genetic code, we've got agentic AI acting as the autonomous workforce, and the closed-loop digital twin is the brain. The final pieces are the nervous system, a digital thread connecting everything from design to production, and a new kind of team structure where IT, operations, and engineering all work together, finally breaking down those old silos.
And this is the end result, a system that can optimize itself. Imagine a machine that can automatically adjust its own settings based on sensor feedback, or a whole production line that reroutes itself to avoid a bottleneck, all without a human needing to step in for every little decision.
This all leaves us with a pretty profound question to chew on. We're building systems that are designed for constant, never-ending improvement. So, what happens when the speed of that evolution, driven by AI, starts to outpace our own human ability to design and plan for it? Because that really is the whole point. For the past 100 years, we've been focused on automation, making machines do what we tell them, just faster. The revolution that's happening right now is about autonomy, building systems that can decide for themselves how to best achieve the goals we give them. And that changes absolutely everything.